Here's section 3.4, exercise 26. And in this one we are supposed to find its inflection points and discuss concavity. So in 26 we have f of x is equal to 2 times the cosecant of 3x over 2. Now, I don't remember what the derivative of the cosecant is. I got better things to do. But I know that cosecant is just 1 over the sine. So what we have is 2 over the sine of 3x over 2. Now that I can take a derivative of f double prime of x, f double prime, f single prime, first derivative. Derivative of the top, which is 0. Okay, so then minus 2 times the derivative of the bottom. Derivative of the bottom is cosine of 3x over 2. Then times 3 halves for the chain rule, all divided by sine of 3x over 2 squared. Okay, so there's the first derivative. Now that 2 and that 2 cancel, so we have minus 3 cosine of 3x over 2, and then divided by sine squared at 3x over 2. Okay, now second derivative. So this is getting ugly. Derivative of the top. Well, I have my minus 3, but then derivative of the cosine is minus sine 3x over 2, but then times 3 over 2 for the chain rule. Now I have the bottom, and that thing is sine squared 3x over 2. Now minus, so minus the thing on the top. Well, the thing on the top is minus 3, so I'll make that a plus 3 cosine of 3x over 2, and then times the derivative of the thing on the bottom. Now, notice, remember, you've got a square, so first I do that. 2 times, and then I had the sine of 3x over 2. But then I have to take the derivative of the sine, that's the next function in. So there's cosine of 3x over 2. But then I have the derivative of 3x over 2, so that's times 3 over 2. Ran out of room there, definitely. And this is all divided by sine 3x over 2 to the 4th, because I squared the square. Phew! Yuck! Okay, so, well, let's see some negative. Okay, so, here's a negative, there's a negative, so negative, negative. That's it for that first part, but then I also, so that's positive, and then I have, looks like 9 halves, and then I've got a bunch of signs, so that's just sine cubed 3x over 2 plus, well, I had a 2 and a 2 that canceled, and then I had the 9 again, 3 and 3, so so I have 9, and I have a cosine squared 3x over 2 plus, or not plus, times sine of 3x over 2. So that's looking a little better, divided by sine to the 4th, 3x over 2. Now I can pull out a sign there and cancel with one on the bottom, and so we end up with 9/2 sine squared 3x over 2 plus 9 cosine squared 3x over 2, all divided by sine cubed, 3x over 2. I gotta stop here a second. Okay, and we're back. That charging went bad. It was dropped all of a sudden. Okay, so we've got all this thing, and now what I notice is I have a sine squared of something and a cosine squared of something. Usually that's 1, except my coefficients have to be the same. So we'll make this 9/2 sine squared of 3x over 2 plus cosine squared of 3x over 2. And what we have left over when we use up 9/2 of this is another 9/2 plus 9/2 cosine squared 3x over 2, all divided by sine cubed 3x over 2. So now that's 1, so we get 9/2 plus 9/2 cosine squared of 3x over 2 over sine cubed of 3x over 2. And that we want to set equal to 0. Now again, a fraction is 0 when its numerator is 0. So we just need the top to be 0, and then we also need to think about when this thing's undefined, and that's when the bottom is 0. Okay, so let's start with the numerator. We'll go to page 2 here, and I don't think I wrote it down, but this was on the interval, open interval, 0 to 2 pi. Quit that. So I should have written that down up here. We're on the open interval 0 to 2 pi, so that will mean we won't have to look for an infinite number of answers. Okay, next page. So the numerator, we had 9/2 times 1 plus cosine squared of 3x over 2. And we want to set that equal to 0. Of course, divide both sides by 9 over 2. And then we see that we've got 1 plus a positive number. That can't be 0. Okay? Never 0. And make sure I had that right, that was a plus. Okay, so if I got all my negatives correct, we had a plus. And I'm pretty sure I got all my negatives correct. And so that's never 0. So now, that was the numerator. So now the denominator is sine cubed of 3x over 2. When is that 0? Well, sine is 0 anytime, right? Sine of x equals 0 when x is any multiple, any integer multiple of pi. So 0, pi, negative pi, and so forth. So between 0 and 2 pi, never mind, we've got to wait. I was jumping the gun a little bit. We have to get to this. So sine cubed is 0. That means sine is 0. And that would mean that 3x over 2 has to equal some constant integer times pi. And so x is equal to 2k pi over 3. Now the question is, for what values of k, integers, is this between 0 and 2 pi and not including 0 or 2 pi? Well, so k has to be positive, and we can check, so we have k equals 1 implies 2 pi over 3. Yep, that's in there. And k equals 2 implies 4 pi over 3. That's in there. But then when we get up to k equal 3, we'll get 6 pi over 3, which is 2 pi. So these are the only two. Okay, so those are my critical numbers. And now I got to look back at the directions and see what the heck they wanted. This is 26. Find points of inflection and discuss the concavity. Okay, yeah. So in this case, we're looking at the intervals from 0 to 2 pi over 3, from 2 pi over 3 to 4 pi over 3, and then from whatever we had there, 4 pi over 3 to 2 pi. So I need to look at all those intervals and evaluate this h double prime. Now what's nice is I know the top is always positive. So actually I'm only interested in the sign on the bottom. Okay, so when I look at this h double prime of, well, let's go with pi over 3. That's definitely in this first interval. Then what I know I get is a positive divided by sine cubed of 3, let's see, what the heck was it? 3x over 2, yeah. So 3 times pi over 3 all over 2. And so that is a positive number over the sine of pi over 2 cubed. And sine of pi over 2 is 1, so that's a positive number over a positive number. Okay, greater than 0, concave up. So in this first interval, we've got a positive concavity or concave up. Now I look at h double prime of here. I guess I'll use pi, because that's between those. So h double prime of pi. Again, that's a positive number over over what? Let's see, over sine cubed of 3 pi over 2. Well, sine of 3 pi over 2 is negative 1, and so this is a positive over a negative, which means that's less than 0. This is concave down. So in this interval, we got a minus, and we have concave down. And then finally, we could do h double prime, and this last one of 5 pi over 3. And that is equal to some positive number over sine cubed of 3 times 5 pi over 3 all over 2. And of course then that's positive, and we've got sine cubed over 5 pi over 2. Now 5 pi over 2, we're back to a positive 1, so that's a plus over a plus. And so that's, again, concave up. And so on that interval, we had a plus and it was up. So if we're looking at our interval, there's 0, there's pi, 2 pi over 3, 4 pi over 3, and 2 pi, then we had, this was concave up, down, and up again. Now, so the question is, did we have inflection points at these x values, the 2 pi over 3 and the 4 pi over 3? Well, let's go back to our function, and well, actually no, because the function was undefined at those points. Okay, so they can't be inflection points. The function's undefined there, and so there are no inflection points. It looked like we might have them at 2/3 pi and 4/3 pi because the concavity changed, but the function was not defined, and so there we are. All right, so that was very long, but number 26.